In the last class, we introduced this formula, stress equal to total stress minus pore water pressure. We'll discuss these total stress and pore water pressure in this class. Total stress. Sigma. Let us consider this as ground level. Okay. From this ground level, there is an arbitrary plane which looked like this, and the area of this plane is A, and the total stress is defined as the total weight on this area A is total stress, that equal to gamma into volume by A, that equal to gamma into area into height by area. Area get cancelled and we will get total stress sigma equal to gamma h. This is the expression. Let's say we'll take a simple case as consider this soil, okay, which we consider right now as uniform. It means that the density is constant. It is not a layered soil. In that case, total stress is directly proportional to H. It means that the stress distribution or this look like this, gamma H. Okay, this is triangle variation. Please look into it. This is triangle variation. Okay, and at any depth H. So this is all known. The main thing for the numerical purpose is, let's say this is a dry soil mass. In that case, this gamma will become gamma dry. Okay, if it is a saturated or a submerged case, in that case, the gamma tends to gamma sat. Okay, so basically gamma will be gamma dry or gamma bulk or gamma sat. How these are classified? With respect to degree of saturation. Let's say in this gamma dry, if we draw phase diagram, gamma dry means oven dry soil sample. We generally take oven dry soil sample. In that case, this is solids and this is air. Volume of solids, volume of void, weight of solid, weight of air, which is 0. So what is degree of saturation? Don't confuse. Degree of saturation is equal to volume of water by volume of voids. It means that how much water present in the voids. As there is no voids in no water in this void, it means that degree of saturation is 0. The bulk density means the soil mass at its natural water content. It means that in the bulk situation, let me erase it. I think I got gamma T. Now we'll discuss gamma bulk. In gamma bulk, there is some water in the voids. So it means that the degree of saturation is in between 0 to 1. In gamma sat, the degree of saturation is So it means it is two-phase diagram. It is also two-phase diagram. This is three-phase diagram. Okay. There is another case. Actually, if gamma sat can be possible when there is a capillary saturation or submergence. We'll discuss about submerged unit weight. There is also a unit weight gamma sub, which is gamma sat minus gamma w. Why like this? We will discuss. Let's take, it is a beaker. In this beaker, I put some soil mass like this. This beaker is filled with water. Okay. It is first filled with water and we insert or a soil mass. In that case, some water will displace and will collect in a measured jar. Okay, let's say this is VW. Let's say, okay, or volume of displaced fluid. We know that hydrostatic pressure P equal to rho GH. It means that P is directly proportional to H. So this plane and this plane, 1, 1, 2, 2. So the hydrostatic pressure will act like this. So if you see here, the pressure here is less, the pressure here is more. It means the pressure at 2, 2 is greater than pressure at 1, 1, which implies the downward force Ft and the upward force Fu, as pressure, downward pressure is greater than upward pressure, P22 is greater than P11, it implies Fu is greater than FB, FD, downwards, this. FD. So there will be a net force, upward force, F net. So there will be a F net upward, which is known as buoyant force. So this buoyant force, due to this buoyant force, the net weight will decrease. The weight of soil mass will decrease if it is in submergence case. So we know gamma, here it is submerged, no? So that's why it is gamma sub. Gamma sub equal to weight in submerged case by, or submerged weight by total volume. Buoyant force Fb equal to this displaced water into its density. Let's say density gamma W and displaced volume is VW, which is equal to volume of soil mass. So that equal to gamma W into Vt equal to, So the net weight equal to soil mass W minus FB by VT, that equal to W by VT minus gamma W VT by VT. VT get cancelled, and we get, as it is submerged, if the soil is submerged, then gamma becomes gamma sat. Okay. Total stress. For effective stress, it is gamma zero. Anyways, we will discuss. This is for total, this is for effective. Okay, so this term will becomes gamma sat, and this is gamma W. Gamma submergence equal to gamma sat minus gamma W.